Now in this, we're going to look at basic forms of SOD, how you can split form if they are single form, how you can make it in basic form, how you can decompose them into basic form. And this always cause lots of issues for students for to convert a SOD to basic form. And this is the basic in which you should understand. If you don't understand this, it will be very difficult for you to solve problems in SOD. Now, what are they saying there? Let's assume you are given square root of what? Square root of 8. They have to split them into a basic form. Now, the first thing you have to do here is that there's something we call a perfect square. A perfect square is a single number in which you multiply 2 times and it gives that number. For example, 4 is a perfect square. It was 2 times 2 that gave 4, right? Another one is that 9 is a perfect square. It is 3 times 3 that gave 9. What else again? What can you think of? 25 is a perfect square, right? 25 is a perfect square. 36 is a perfect square. 6 times 6 gives 36. 49 is a perfect square. 7 times 7 gives 49. 64 is a perfect square. 64 is a perfect square. 81 is a perfect square. 100 is a perfect square, and so on and so forth. So any number that a single number you multiply in 2 places that give a number, that number is a perfect square. So that now comes to this particular case. Here is that you are going to think of a perfect square and non-perfect square that you multiply together that will give us this 8. What I always tell my students is that always make sure that if you can divide this number given to you, you can divide it with a non-perfect square or a prime number, you should be able to get a perfect square. If you divide with a non-perfect square and you get a perfect square, those are the numbers you are going to use. What am I saying in this non-perfect square? It means a number that most examples under non-perfect square, prime numbers, they are non-perfect square. If you have 2, 3, 5, 7, 11, 13, they are a non-perfect square. But they are not limited to this. They are non-square that you can use as a basic form. Like this 10 now. 10 is also is a non-perfect square, but it is not a prime numbers. But it's also a non-perfect square. So what you should realize is that the non-perfect square is that if apart from prime numbers, any number that one is the multiplication of 2 prime numbers that gave that number is a non-perfect square. Another one, when you have 15 also, this 15 is not a prime number, but you know that 3 times 5 gave 15. These 3 and 5, they are what? They are prime numbers, and they give what? They gave 15. So it means that this one also is a non-perfect square. As you continue solving, you understand. Just know that what you should be more concerned about is this perfect square. When it's a perfect square to divide that number, if it gave you a prime number or a number that when you multiply 2 prime number is what gave that number, then that number is what you are going to use. For this one, when you check this, when I divide this thing by 2, 2 goes in 8 is 4. I can rewrite this thing as saying 4 times 2. You can see that this 2 is non-perfect square, 4 is a perfect square. So it means this thing can be written like this. Now, square root of 4, you know is what? Is 2. You bring that outside. It means this basket or this square root has left this 4 that has become ordinary 2. Now, root, this 2 is still under the coven, or is still under this particular root because it is not a perfect square. So if you get the square root of 2, you get a decimal point number. And I told you that you either leave it like this. This is the best way to live, but this is the way you should live your SOD. You should not convert this how SODs looks like. Did you get that logic now? So this is how SODs looks like. Let's assume they gave you square root of of 27. As you already know, this 27 is, when you check a non-perfect square, we have 3 is a prime number. You can say 3 times 9, because 9 is a perfect square. 3 is non-perfect square. Square root of 9, it is 3. It means this thing has become, square root of this 9 has become ordinary 3. Root what? Root what? Then this 3 will be under this root. So that is what? That is that. So let's now look at more big numbers. This one are just small numbers. So let's look at big numbers. Let's assume you are given square root of what? Of what? 162. Now, when I check the square root of 162, what I always do is that, why can't I say 162 divided by 2? 2 here is 1, 2 here is 81. So it means 81 is a perfect square, and 2 is non-perfect square. So I can use this 2. So it means what you have is, well, I have what? Root what? Let me make it easier for you. Root 81 times root what? Root 2. You know, when I was taking you the composition of, so I did this thing, if you write, it can also be like this, 81 times 2. That is why those knowledge is very important for you to move forward. So root 81 is what? It is what? It is 9, right? Times root 2 will still be root 2. You can't convert it to what? To decimal. It's still root 2. So 9 times root 2. I told you earlier, multiplication doesn't care. You get, but it will not multiply what is inside. There's an invisible one here. 9 times 1 is what? That is 9 root what? Root 2. This is your what? Your final answer. Now let's assume we are given another one. We have what? Root what? Root 54. How do you solve this? If you divide this thing by 2, let's say 54 divided by 2. 2 in 5 is 2. So this is what? This is 27. I know that this 27 is not a perfect square, so I can't use this one. I will take again. Why can't I use 9 times 6? 9 times 6 is 54. Because 6 is a non-perfect square. Because if you multiply 2 times 3, these two prime numbers make up this 6. And this 9 is a perfect square. So when I divide this by a perfect square 9, I will get 6. And 6 is a non-perfect square. So I'm going to use these two numbers. So what is going to be here is going to be what? Square root of what? 9 times 6. And square root of 9, it is 3. Square root of 6, I told you what? You just put it at the what? At the back. So that is how that one goes. Let's look at another one. Let's say you are given 98. Square root of 98. So how do you solve this? When I divide this 98 by 2, I always like dividing by 2. 2 goes in 9, it is 4, right? And 2 goes in 18. 2 times 9 is 18, is 49. So I can use 49 is a perfect square. 7 times 7 gave me 49. So I can turn it to something like this. 49 times 2. This is what will be. Square root of 49, it is what? It is 7. And what? Square root of what? You put this to what? At the what? At the back. So there's another one I want us to look at. Let's assume you are given something like this. They gave you, let's say, 3 roots, let me say 3 roots 72. Now this becomes problem. Now it is not a problem. Look for this one, decompose this one to basic form. So 72, let me just divide it by 2. 7 goes in 7 is 3. 2 goes in 7 is 3. You mean that 1. 2 goes in 12 is 6. That is 36. It means, and 36 is a perfect square. 2 is not a non-perfect square. So I can use this 2. So I will have 3. You open a big bracket. This is going to be what? 36 times what? Times 2. Square root of 36 is what? It will be what? It will be 6. That 6 will now come here to multiply this number at outside. This number that is outside, this square root of 36, which you got 6, will now be 3 times 6. Then you have left with what? Root 2. So 3 times 6 is what? Is 18 root what? Root 2. So this is how this particular one works. Let's now look at another. Let's say we are given 7 root what? Root 80. So how do you solve this? You know, if I use 4 to divide this, 4 in 80 is 20. That is 4 times 20 is 80. No, you can't use this one. Though you can use it, see we can still simplify this. But I just want you to understand this thing clearly. 4 is a perfect square, but this 20 is not a non-perfect square. It is not a non-perfect square because you can't multiply two prime numbers to give you 20. It's 4 times 5. 4 is not a prime number, so you can't use this one. When you think again, what else can I use here? You think, what else can I use here? You have to like use the brain. Okay, what can't I use? If I use 10 to divide this, I'll still get 10 and what? And 8. And 8 is what? 8 is not a non-perfect square. So you can still simplify this one to further. Let me now show you how to simplify this thing. If I give something like this, let me show you something. So you can have, let's say you have 4 times 20. I'll show you something. This 4, the square root of 4 is what? Is 2. Multiply this this square root of 4 is 2. I told you I'm going to multiply what number at the back. So that will be 7, 2 times 7, that is what? 14 root what? Root 20. Now, you should also know that this root 20, it still has a perfect square in it, because if you have 4 times 5, you get 20. So it means I can still rewrite this thing as saying 14, then you have what? 4 times 5. Square root of 4 is what? Is 2. So I'll multiply with this one again. 2 times 14, I will get 20. That is 28 root what? Root 5. Now, this is another way of doing this particular thing. If you are finding it difficult to think of a number that you multiply together, that will give us what? That will give you 80. But there's another way to do this particular one. So this 80 now, when I see this 80, I can use a perfect square to divide it. If I use 16 to divide this thing, 16 goes in 80. We can be using perfect square to divide. 16 goes in 80 will give us 5. Did you know that? Because when you say 16 times 5, 5 times 6 is 30, you made that 3. 5 times 1, 5 plus 3 is what? Is 8. So 16 and 5. 16 is a perfect square times 5 is a non-perfect square. So this thing here, this what is here, I can still go, instead of going through all this stress, if you know what you are doing, if you are very good at your stuff, you can just say like 7. You can go like this. You can say 16 times what? Times 5. So square root of 16 is what? Is 4, right? So that 4 will now multiply this 7. 4 times this 7 will have what? 28 root what? Root 5. So this is what you have. You can see it's the same thing with what is here. So this is basic one. There are a lot of questions, big numbers they will give you. Just find a way to decompose it, or use a perfect square number to divide it, or a prime number to divide it. If you use a perfect square number to divide that big number and it gave you a non-perfect square, it means those are the numbers you are going to use. The non-perfect square and the perfect square is to divide it. If you use a prime number to divide it and it gave you a perfect square, it means that prime number and that perfect square it gave you is what you are going to use to get your basic form. So our next class will look at how to convert this basic form back into a single surd. So that is what we are going to look at. So let's move on.